Hi, this is Mr. Warden. Welcome to part one of a video on how to factor some fancier, more complicated polynomials. This is related to level 7b, which is, let's see here, let's go to it. So these types of questions where you've got something cubed and there's a whole bunch of stuff that shares the same factor and you can clean it up. Here we've got something cubed, but things share similar factors, so we can clean things up using greatest common factors. All of these have greatest common factors that you can tidy up. Okay, so what I'm going to do is I'm going to work through a variety of these. So these three here, the first three here, are all trinomials, and you're going to be able to factor out greatest common factors and then use basic trinomial factoring tools. These two, you'll be able to factor some stuff out, a greatest common factor out, and then be looking to see if there's any kind of special case situation. The ones down here are all going, once you factor stuff out, you're going to have to use factor by grouping. So those are kind of the three basic situations that you might be dealing with. I'm going to actually do one more. I'm going to put one more in here. So 1 second. I put one more in here. And this one, you could certainly factor it using some of the tools we've got. However, this one will be made easier if you follow a couple of steps. You can see all these crazy graphs over here, but we're not going to pay so much attention to that for the purpose of this. So what I'm going to do is I'm going to look through all of the terms. So this is a term, this is a term, and this is a term. We call this the square term, the linear term, and the constant term. Sometimes you could call it the second degree, first degree, and 0 degree term. But we're going to look for something that they all share in common. All right, so they don't share a variable in common, but 22, 66, and 44, you can probably pretty quickly see that they share an 11 in common. But since it's all even, you might also notice that they share not just an 11, but a 2, which means they share a 2 times 11, which would be a 22. So I will copy this into the next cell, and I'm going to factor out a 22 from all parts of this. So 66 divided by 22 will be 3, and 44 divided by 22 will be 2. And now I have something that's much easier to factor inside of there. So now we'll copy one more, and we will factor this thing. So I've got x squared plus 3x plus 2. I need two factors of 2 that add up to 3, and those will be 2 and 1. So I'm just going to say x plus 2 and x plus 1. And we are done factoring that one. And so that was actually pretty straightforward once we noticed that there was a 22. Now, if you didn't notice there was a 22, maybe you would have noticed that there was a 2. Once you pulled out a 2, I'll show you how that might have looked. You could have gone a couple of steps. Maybe you factor out a 2. Okay, so that becomes 11, and that would become 33, and that would have become 22. And then you might have noticed that you could factor an 11 out of all of that. Okay, and if you're factoring an 11 out, then this 2 becomes a 22. That becomes a 1. So don't fret if you didn't see the 22 on the first pass. You could still get there by just going those steps. Okay, let's take a look at the next one. So this next one, copy it, I'm going to pasta it, copy pasta. So I'm going to look through all of these. I'm going to put parentheses around the whole thing. And the first thing I notice, they all share an x. That's a cubic term, that's a square term, that's a linear term. That's third degree, second degree, and first degree x's. The smallest one tells me how many I can take out. I can take out x to the first, or just x. So that x will drop this down to x to the second. Now it's a quadratic term. That'll drop that to x to the first, so it's a linear term. And this drops this just to a constant, so it's the constant or 0 degree term. Now I'm looking through here, and to be fairly obvious, pardon me, that all of these terms share a 4 as a factor. We can definitely get a 4 out of them. So let's get a 4 out. So take a 4 out of here and we'll have a 20. Take a 4 out of here. I'm going to come back to that one because it's going to take a little more doing. That's a 15, but 224 is definitely divisible by 4. All right, 24 is 6 times 4, and 200 is 8 times 4. So I've got an 86 now. At this point, there are no more things that I can factor out of that. And so I'm going to have to go to some of my tools to work things out. So I'm going to take a look here, and I'm going to look at 20 and 15. Okay, those are my first and last terms. So I'm just going to be using the 7a tools here. So I need a sum of 86. Okay, and 20 plus 15 certainly won't do it. So I'm going to need to, I can multiply that together. 20 times 15 will be 300. But I'm going to go ahead and break that down into its factors because it may not be obvious to you what factors of 300 would add up to 86. So that's going to be 3 times 5. And now I'm going to start looking for ways I can mix and match. 20 and 15 they add up to simply 35. So that's not enough. So I need some number to get bigger. So let's take a look. We got 5 and 5. So we can do 5 times 5 and then double that. 5 times 5 would be 25 times 2, which would end up being 50. And then we got 2 times 3, which is 6. 50 plus 6 doesn't get us there. And then maybe that doesn't work. So maybe we go with 6 times 5. So 6 times 50. That's too much. That'll get us 6 times 25 will get us to 150. So it's possible we actually won't have neat and tidy factors. I'm going to pause this and consider this one. And so I've analyzed this a bit further, and what I've determined is that is as far as you're going to be able to factor it using the tools we've got so far. The factors of this particular one are going to be irrational. I'll go to another page where you can see it. I've used a tool called the Quadratic Formula. I've graphed this without that 4x in the front of it, and what I get are these factors, these x-intercepts, I should say. And one can factor it. It's just going to involve radicals, and don't worry about going any further. And I didn't include any that involved radicals. So we're going to move on to the next one. The next one will be much more doable. Let me clear that out. However, once you factored it out the 4x, you are actually good to go for this level. Okay, but don't worry, I'm not giving you any that would lead to that. Let's take a look at this one. 54x cubed minus 45x squared plus 9x. Okay, so I see immediately I've got some x's I could pull out. And this is the first degree. I've got a second degree and a third degree. So I've got this is an x to the first, x to the second, and x to the third. The smallest one determines how many I can pull out. I can pull out one factor of x. So that drops that down by one factor. That's what an exponent means. It means how many factors there are. Drops that from 2 to 1, which we don't generally write. And that drops that down to 0 factors of x. And now we look through 54, 45, and 9. It should be obvious that those are 9s, that 9 is a factor of those. So I can factor that down to 6, and I can factor that down to 5, and I can factor that down to 1. And now we can factor this one, and this one definitely we could factor using that big X thingy. So I'm going to make the big X. And I've got a negative 5 here and a 6 times 1 here. So I need two factors of 6 that add up to negative 5. Those would be negative 2 and negative 3. And that will do the job. So let's go ahead and factor what's inside there using that. So I'm going to have a -2 and a -3 involved. So let's actually break this up into a -2x and a -3x. And then we'll group it further. So I'm going to group this side inside the grouping plus grouping this side inside the grouping. Okay, so I've done that. And now we'll see what we can pull out here. Okay, so we can definitely pull out a 2x from here. And that will drop that to a 3, and that's just an x. And when I pulled out a 2x here, it became a 1. Over here, I can pull out a 1 or a -1. I'm going to pull out a -1 because that'll change that to positive and that to negative, and now I have matches. Okay, and now I can say, so I've got a 3x minus 1 and a 3x minus 1, so I'll say 9x, and then that's going to be times, and this is for factoring this stuff inside these parentheses. I get a 3x minus 1 shared by the 2x and the minus 1. So I'm going to say 3x minus 1, and then that's going to be times 2x minus 1. And I am done factoring that. Okay, I'm going to do just one more, and then I'm going to pause the video because it's long enough, and after this one, I'm going to do a video in which I'll deal with these three, and then I'll do a third video in which I deal with these three.